In this video, we will be talking about solving absolute value equations. So here we have equation A equals the absolute value of 2x minus 6, and 2x minus 6 is in these kind of straight lined. And what this means that the distance of this from 0 is 8. Now, if you graph this on a number line, we have 0 in the middle, we have 1, 2, 3, 4, 5, 6, 8 right here. So 2x minus 6 could be here, distance of 8 from the 0, but it could go into the other direction. 1, 2, 3, 4, 5, 6, 7, 8 right here. Could be here, 2x minus 6. So with how we're going to open this absolute value equation is we're going to have two possibilities. The first one is 2x minus 6 is actually negative 8, or it could be positive 8. So you're when you're opening your absolute value, consider two different possibilities. You always have to consider two. Okay, so solving, adding 6 to both sides, we have 2x equals negative 2, x equals negative 1, and then continue. 2x equals 14, so x is 7. So x is either negative 1 or 7. We have two solutions to this equation. Okay, now let's talk about how to solve this absolute value equation. And first I want to point out, how is this equation different from the one that we just did? And I hope you notice that the absolute value here in this equation is not isolated. It's not by itself. There is an absolute value and a regular number here. And that is a problem. We have to actually, first step is to isolate absolute value before we can open it up like this. Okay, so we're going to bring 4 to the other side, and we have 5x plus 2. Always do your cleanup before you jump into solving. Okay, so this is equals 13. So using the same reasoning as here, 5x plus 2 could be either positive 13 or it could be a negative 13. So it could be on the positive side of 0 or on the negative side of 0. What it tells us that the distance of 5x plus 2 to 0 is 13. Okay, now we can solve it. So we got x is either positive 11 over 5 or it is negative 3. Now let's talk about absolute value functions, not absolute value equations. And one of the questions that comes up is, do the graphs of absolute value functions always intersect a vertical axis and or horizontal axis? So, and as following pictures show that yes, absolute value functions will always cross the y-axis, but they will not always cross the x-axis, right? For example, this function crosses the x-axis. This function touches it once and it kind of like sort of bounces off of it. So this will, we will say that it crosses the x-axis once. This one crosses the x-axis twice, and this one doesn't cross x-axis at all. So we have 3 different possibilities. Okay, so from that stems this question. For the function f of x equals absolute value of 4x plus 1, close absolute value minus 7, find the value of x such that f of x equals 0. So f of x equals 0. We're going to substitute the 0 in for f of x, and we get 0 equals absolute value for x plus 1. Close the absolute value sign minus 7. So we got our absolute value equation. And we need to isolate the absolute value, bring 7 to the other side. So I have 7 equals absolute value for x plus 1. Now we are ready to open up the absolute value. And we're going to get 2 separate equations at this point. So 4x plus 1 could be equal to positive 7, or 4x plus 1 could be equal to negative 7. All right, let's solve each equation separately. 4x is either 6, in this case x is 6 over 4 or 3/2. And for this one, 4x equals negative 8. So x is going to be negative 2. So again, we have two solutions here. But again, the question is, all of the absolute value equations going to have 2 solutions, and as shown by these graphs, the answer is no. Sometimes there will be no solutions, sometimes there might be one solution. But so for example, here the question is, how many solutions does the following equation have? Let's actually start it. So I'm going to subtract 2 on both sides. I have absolute value 3x minus 5 equals negative 1. Look, this is a problem right here. It says the distance from 0 of this expression is negative 1. And we know that distance could not be negative. So this has no solutions. Basically, your absolute value expression could never be equal to a negative number. It could be equal to 0. In that case, we would have only one solution, but it will not, it cannot be equal to negative values. So as soon as you see that, and it's just the absolute value by itself equals to negative number, then there is no solution. Okay, because if there are other numbers involved, like once you bring them over, this situation may change. Okay, so make sure you've isolated your absolute value expression on one side before you draw your conclusions. And I want you to try this problem right here. F of x equals absolute value of 2x minus 1, close the absolute value, minus 3. Find the value of x such that f of x equals 0. And I want you to pause here, and we're going to take a look at and continue solving this problem. And we're going to look at one more situation with absolute values. My next example is how to solve an equation like this. You have absolute value equals to another absolute value. So if you think about it in terms of the distance from 0, what this equation says is that the distance from 0 of this guy is the same as the distance from 0 of this guy. So what could happen, what are the situations? How could that happen? So here we have 0, right? So they're either on the same side, let's say 4x plus 1 here, and 2x minus 2 also here, right? They both could be on the other side, 4x plus 1 and 2x minus 2 also. So in both of these cases, they're actually equal to each other, right? So they could also only be either 4x plus 1 equals to 2x minus 2. So this equation, it describes both of these situations when they're equal to each other. What could also happen is that one is on one side and of 0 and the other one is on the other side of 0. They're still equidistant from 0, but they're on opposite sides. So one should be positive and one should be negative. They're opposites of each other. And that translates into the following equation. 4x plus 1 is the opposite of 2x minus 2. So you put the negative sign in front of one of the expressions. Which one? It doesn't matter, because it just says that one is the opposite of each other, so of the other. So we read the minus sign here as the opposite. We know that the minus sign could represent different things. It could represent a negative number, negative value, or operation of subtraction, or the opposite. So in this case, it's the opposite, but we treat it the same way as usually. So just bring it in, open the parentheses, we have negative 2x plus 2. And now combining the x's on one side and numbers on the other, we have 6x equals 1, so x is 1 over 6. Okay, and then solving this equation, we get 2x equals negative 3, so x is negative 3/2. So that's how you approach this type of equation.